Now we're getting into the concept of auto-scaling groups. So in real life, basically your websites and applications will change and they will have different loads. So the more users, the more popular you're going to be and the more load you're going to have. So in the cloud, as we see, we can create and get rid of servers very quickly. And so there's one thing that an auto-scaling group does very well. It is to scale out. That means add EC2 instances to match an increased load, but also scale in, remove EC2 instances to match a decreased load. And then finally, we can ensure that the EC2 instances can only grow to a certain amount or decrease to a certain amount. And this is where we can define a minimum and a maximum number of machines running in an ASG. Finally, we can also have a super cool feature of the ASG, which is to automatically register new instances to a load balancer. So in the previous lecture, we did register instances manually, but obviously there's always some kind of automation we can do. So in AWS, what does it look like with the graph? Well, here is our beautiful auto-scaling group. It's a big arrow. And so the minimum size, for example, 1 here, is the number of EC2 instances you'll have for sure running into this auto-scaling group. The actual size or desired capacity parameter is the number of EC2 instances running at the previous moment in the current moment in your ASG. And then you have the maximum size, which is how many instances can be added for scale out if needed when the load goes up. And so that's super useful. What you need to know about is the minimum size, desired capacity, and maximum size parameters because they will come up very often. Also note that scale out means adding instances and scale in means removing instances. So now how does it look like with a load balancer? Well, here is our load balancer and web traffic goes straight through it. And we have our auto-scaling group in the bottom. And basically the load balancer will know directly how to connect to these ASG instances. So it will direct the traffic to these 3 instances. But if our auto-scaling group scales out, so if we add EC2 instances, then the load balancers will also register these targets, obviously perform health checks, and directly reach traffic back to them. So load balancer and auto-scaling groups really work hand in hand in AWS. So ASG, they have the following attributes: a launch configuration, and we'll be creating one in the next lecture during the hands-on. But the launch configuration has an AMI and an instance type, EC2 user data if you need it, EBS volumes, security groups, SSH key pair, and as you can see, well, this is quite common, quite the same things that what we've been creating from before when we launched an instance manually. Obviously, they're very, very close. You also set the minimum size, the maximum size, and the initial capacity, as well as the desired capacity. We can define the network and the subnets in which our ASG will be able to create instances, and we'll define load balancer information or target group information based on which load balancer we use. Finally, when we create an ASG, as we'll see, we'll be able to define scaling policies. So what will trigger a scale out or what will trigger a scale in. So we're getting to the auto-scaling part of auto-scaling, which is the alarms. So basically, it's possible to scale your auto-scaling groups based on the CloudWatch alarm. And we haven't seen yet what is CloudWatch, but as I said, Amazon is kind of a spaghetti ball, so don't worry, follow with me. So the CloudWatch alarm is going to be something that's going to monitor a few metrics. And when the alarm goes off, so when a metric goes up, it'll say, okay, you should scale out, you should add instances. And then when the alarm goes back down or there's another alarm saying it's too low, then we can scale in. So basically the ASG will scale based on the alarms. And the alarms can be anything you want to monitor, such as like the average CPU. And the metrics are computed as an average overall, okay? It doesn't look at the minimum or the maximum, it looks at the average of these metrics. Based on the alarm, basically we can create scale out policies and scale in policies, as I said. So there are rules and there are new rules for auto scaling. We'll be seeing them in the hands-on, but now you can basically say, okay, I want to have a target average CPU usage in my auto scaling group. And basically it will scale in and scale out based on your load to meet that target CPU usage. You can also have a rule based on the number of requests on the ELB per instance, the average network in, average network at. So really whatever you think the better scaling policy is for your application, you can use. These rules are easier to set up than the previous ones, and they can make more sense to reason about, saying, okay, I want to have 1,000 requests per instance from my ELB. That's easy to reason about. Or I want my CPU usage to be 40% on average. Now you can auto scale also according to a custom metric. And basically, we can define a custom metric, say the number of connected users to our application. And to do this, we'll create that custom metric from our application. We'll send it to CloudWatch using the put metric API. And then we create a CloudWatch alarm to react to low or high values of that metric. And then these alarms will basically trigger the scaling policy for the ASG. So what you should know out of it is that the autoscaling group isn't tied to the metrics AWS exposes. It's also be any metrics you want, and it can be a custom metric. So here's a small brain dump on things to know on your ASG. First of all, you can have scaling policies for your ASG, and they could be anything you want. It could be CPU, network, it could be a custom metric you define, or even based on the schedule if you know in advance how your visitors are going to visit, for example, your website. If you know they're logging in very early at 9 a.m., maybe you can be proactive and add more instances proactively before users arrive so they have a better experience. Also, ASG can use launch configurations or launch templates, and launch templates are the newer versions of launch configuration, and they're recommended to use moving forward. And if you wanted to update an autoscaling group, what you need to do is to provide a new version of that launch configuration or that launch template, and then your underlying EC2 instances can be replaced over time. If you do attach an IAM role to your autoscaling group, that means that the IAM role will automatically be assigned to the EC2 instances that you launched, okay? And an autoscaling group in itself are free. The only thing you're going to pay for is the underlying resources being launched. So that means your EC2 instances, attached EBS volumes, etc., etc. If you have an instance under an ASG, the beautiful thing is that if somehow the instance gets terminated, then the ASG will realize that your instance has been terminated and will automatically create a new instance as a replacement. And that is the whole purpose of having an ASG, really. It's that extra safety that it gives you to know that your instances will be automatically recreated, as a new one in case something goes wrong. And when would an instance be terminated? Well, instances can be terminated, for example, if they're marked unhealthy by a load balancer. And so your SG knows, okay, your load balancer thinks that your instance is unhealthy. The better thing to do is to terminate that instance and replace it by creating a new one. Okay, so remember, an ASG create automatically new instances. Okay, it doesn't restart, it doesn't stop your instances. It literally just terminates them and creates a new one as replacements. So that's it. I hope you liked it, and I will see you in the next lecture.